Folks, today we're going to talk about miniaturization and speed. Two things that are absolutely non-negotiable in the world of modern automotive engineering. If you look at the design constraints of any new vehicle platform today, you'll see a constant struggle. We need to integrate more sensors, more cameras, more high-speed communication modules. But we also need to consider the challenges related to size, weight, and risk of signal failure. For years, the industry has relied on the tried and true FAKRA connector. But in order to enable the next generation of connected and autonomous vehicles, we need to take those connectors up a notch. So, it's time we talk about the FAKRA-Mini. Hi, I'm Amelia Dalton, host of Chalk Talk. In this episode of Chalk Talk, Kirk Ulery from Molex and I explore the trends driving a need for external and internal data connections in automotive applications. We also investigate the benefits of the FAKRA-Mini Interconnect system and why the new locking and shielding mechanisms make this system rugged enough for the harshest automotive environments. And before we get started, don't forget to click that link. There you can find even more information about this topic from Molex. Hi, Kirk. Thank you so much for joining me.
You're welcome. I'm very happy to be here.
Excellent. Okay, so we're talking about high-speed FAKRA-Mini connector systems today. Now, we have covered FAKRA solutions in the past here on Chalk Talk, and I know they are a really good fit for automotive and transportation applications. Is that right, Kirk?
Yes, that is. And the high-speed FAKRA Mini that we're talking about today was specifically designed for automotive applications, whereas the original FAKRA connector was a modification of a commercial standard that had been around for years.
All right, so talk to me about these kinds of applications.
When we look at coax in vehicle applications, there are actually three different signals that we handle over coax. The first one I like to start with are what we call radio frequency applications, or RF applications. And that's what most people are familiar with coax products. Basically, any signal that can be transmitted over the air can be received in the vehicle. The ones that we've all been familiar with for years are terrestrial radio, things like AM, FM, digital audio broadcasting, those types of things. And over the last 15 or 20 years, we've had a lot of other signals coming into our vehicles. When we look at satellite signals for satellite radio, for example, even some of the safety applications that we're becoming more and more used to can all be received by these coax cables through the antenna. The GNSS that we mentioned are the global navigation satellite systems. So if you've got GPS direct in your car, there's an antenna for that. And then our cellular data also comes into the vehicles. We're trying to get safer and safer with our vehicles. So we look at things like hands-free, actually having the car have that receiver so you don't necessarily need your cell phone. And then there's some dedicated communication signals that come into the vehicle. Things like Bluetooth and Wi-Fi that are primarily internal to the vehicle. But then there's V2X, if you've heard that term, which accounts for what we call vehicle to anything. And a lot of these are safety type of systems where the vehicles can talk to each other. You can get live traffic updates, those types of things. Occasionally, I get a note in my car that says, hey, this next traffic light has a camera on it, just to be aware. And then the final one I want to talk about are the RKE, or remote keyless entry, and TPMS, which is tire pressure monitoring systems. So there are a broad range of signals and a broad range of frequencies, and the products that we have today can handle any one of those frequency applications.
So, talk to me about the digital camera applications.
Well, digital cameras are another area that's really increased the growth of coax in vehicles tremendously. In 2015, the US government mandated backup cameras on all vehicles as a safety system. And those original cameras were analog cameras that required 3 or 4 individual analog lines. By using a technology that we call power over coax, we're able to come up with a digital camera system that only has a single coax cable plugging into the camera. As automotive OEMs wanted more resolution in the camera, the digital cameras make a lot of sense for the backup camera And then we started looking at other areas, and we've come up with the surround camera system, which puts 4 separate cameras in a vehicle to give you that full 360 view. And we're seeing a lot of other areas for side view, blind spot monitoring, even some of our customers that are replacing the interior rear view mirror with a camera in the back of the vehicle. This is a great thing to have if you've got an SUV where you pile a lot of stuff in the back, and all the mirror shows you is what's in the back of your vehicle. Whereas a camera mirror has the camera on outside the vehicle, and it literally eliminates everything in the vehicle.
So you talked about this a little bit earlier, but what about vehicle networking?
Well, also with the networking, we're working with several of the chip manufacturers, and they're looking at doing Ethernet over coax specific for vehicle application. Traditional Ethernet required 2 twisted pair cables, so that you needed at least 4 conductors for traditional Ethernet. We do have some standards for what we call 2-wire Ethernet, or if you've heard the term SPE, which is single pair Ethernet. But again, those are shielded, jacketed, twisted pair cables, which are relatively expensive compared to a traditional coax. So we're developing these systems around different chipsets that can transmit an Ethernet signal back and forth over a single coax connector. This is giving us more of what we call a data pipe in the vehicle and allowing us to transmit more and more data within the different systems of the vehicle.
All right. So, Kirk, talk to me a bit about the topology of the domain architecture. Controller locations determine the routing layout, right?
Correct. And most vehicles today use what we call a domain architecture. And as you add more safety features to the vehicle, each one of these features requires a separate controller. What we're showing here, we start with the antenna locations, and you can see all the lines in red that highlight the different areas for the signals I talked about previously, primarily those RF ones coming into the vehicle. We show here the vehicle to X, vehicle to vehicle communications, different Wi-Fi, and you have different receivers for those signals. And as we add the cameras, and what I've laid in here is a very simple camera system today. I'm only showing 5 cameras. We've got the right, left, front, and back, which highlight the surround camera system. And then we have cockpit monitoring cameras. But looking at some of the vehicles on the road today, you can have as many as 10 to 12 cameras in the vehicle for things like blind spot monitoring, side view, collision avoidance, those types of things. So you can see as we layer the purple lines in there, it gets a little more complex. And then getting into some of the RF-based systems that can also come in over coax, we've got things for blind spot monitoring, park assist, those features that we become accustomed to in our vehicles. And as we get closer to autonomous vehicle systems, there are different LiDAR units that are going to require a lot more data. And those are the yellow systems that we lay in here. And you can see that each one of these systems requires a separate controller and the wiring associated with that controller from the sensors that are outside the vehicle to the individual controllers. So it's a fairly complex wiring scheme, and it takes a lot of wire, or coax cable in this case, to get all of these signals to the different controllers.
Absolutely. So, Kirk, how does zonal architecture compare with the domain architecture you just discussed?
Well, in the zonal architecture, the basic theory behind zonal architecture is that we have what we call a zone controller. And each zone in the vehicle here is represented by the 4 green boxes on the outside corner of the vehicle. And the zone controllers are connected to a central computer by a high-speed backplane, which is typically an Ethernet system. We use Ethernet because the chips are readily available. It's a technology that's been very well understood, both in automotive and all sorts of other communications industries. Now, in this case, we start with one of the zones. And when we bring in the zone, you can see that instead of having individual systems going to the zone controller, every one of those sensors in that zone goes to that single zone controller. And as we go around the vehicle, we'll also highlight that in each zone, the systems come into that controller. And what this does is it greatly simplifies the wiring of the vehicle. Instead of having to run the collision avoidance, for example, from the rear of the vehicle to a controller in the front of the vehicle, it only has to go to the local zone controller. So it simplifies the wiring in the vehicle and allows us to come up with much better methods of putting these systems together.
All right. So, Kirk, let's talk about high-speed FAKRA mini solutions from Molex. Now, we're looking at a big improvement when it comes to performance with these solutions, right?
Yes, very much so. If we look at the original FAKRA design, which, as I mentioned earlier, was based on an existing connector, that connector has been around for about 60 or 70 years in terms of the individual coax and was capable of carrying signals up to about 3 gigahertz, which was fine for the terrestrial radio, the satellite, and even some of the video signals that we do for power over coax. Now, within the industry, we developed a system we called FAKRA-2 that was capable of handling signals up to 6 gigahertz. The HFM is capable up to 20 gigahertz. And what we're highlighting here are the impedance curves for these three different systems. And if you think about the impedance mismatch that we show in the middle of our graph, think of that as a speed bump. And the smaller the speed bump, the easier it is for the signal to go quickly over it. We've all been in parking lots that have very aggressive speed bumps. And if you don't notice it quick enough, it typically sends you flying out of your seat. In this case, what we want you to think about is the fact that that speed bump is very low for the HFM product, which enables us to do those 20 gigahertz signals that allow us to do things like 5G cellular, multi-gig data, and even video streaming within the vehicle over these HFM products.
So, Kirk, how do these solutions compare with standard FAKRA in terms of size?
Well, the size is a key issue here. I like the fact that we put the mini in the name of the product. Again, the traditional HFM product, what we show here in the upper left corner are 20 individual FAKRA connectors. You can see it takes up a lot of board and panel real estate. The board in the upper right corner has 5 4-port HFM products. So we have exactly the same number of coax interfaces on those two boards, and we end up with about an 80% smaller footprint in these multiple coax applications. The lower boards show exactly the same situation, again, highlighting the fact that you can come up with smaller boards or add a lot more signals in the same space by switching from a standard FAKRA to the HFM product. The other thing to note with our HFM product is that it is an industry standard, and Molex has licensed our design with Rosenberger. The HFM is technically a Rosenberger trademark, but Molex is licensed to use the trademark, and we perform a lot of design and manufacturing testing in conjunction with them to make sure that our products will mate seamlessly to their products. And with this product, there's a standardized design for the terminals such that our terminals fit in their housings and their terminals fit in our housings. So what that gives you as a customer is the assurance that there will always be product available. And in automotive, we don't always have the ability to control both sides of an interface because they can be manufactured by 2 or 3 different manufacturers. So the idea behind HFM is that there will always be a readily available product for you, which eliminates the need for future obsolescence.
So, Kirk, what does the typical transition from FAKRA to FAKRA-Mini look like?
Well, it's interesting because we've had this slide actually for a couple of years, and right now we're seeing a crossover to where we're now at a point where we're selling more HFM or mini FAKRA in vehicle applications than we are the traditional FAKRA. Several of our automotive customers have mandated that all new designs have to use the HFM or the mini FAKRA product going forward. And if you need to use the standard FAKRA, it requires an engineering deviation. So we're going to see significant increases in the adoption of the HFM product. Molex is well prepared for this. The header products are already currently available in the Mauser showrooms, and the cables will be available early next year. Looking at the products that are currently available through Mauser, we have 4 different header options available. We have a single right angle PCB mount, and there are 2 different dual PCBs. There's a vertical mount and a horizontal mount. Depending on how much space you have in your unit, you can use either one of these. And then the most popular one that we sell is the quad or 4-port right angle header. This one was originally designed for that 4-camera system I mentioned earlier, but we're seeing a lot of other applications. And as I mentioned, we've got about an 80% footprint reduction. These products are rated for minus 40 degrees up to 105 degrees C, and primarily designed for inside some type of a controlled environment, a passenger compartment or other area. We are developing waterproof systems. So if you need those, you can get in touch with us. But for today, the standard products are all unsealed.
Okay, so a crucial element to zonal architecture is the zonal gateway, right? So, how can FAKRA Mini solutions help me here?
Well, in this case, it helps you build a smaller zonal gateway. Within the gateway, the FAKRA cables coming in are a small part of the electronics required for the zonal gateway to communicate and operate properly. So by going to a smaller HFM product, it gives you more opportunity for other systems. In this case, we're highlighting a cutaway view of a typical zonal gateway. And you can see that the HFM is featured prominently in the front corner, but we also have other systems available, such as our HS Autolink 2, some of our stack products that are headers we can stack together. So there's a broad range of Molex products available as you're designing a zonal gateway. We encourage you to check the technical resources both on the Mouser website as well as the Molex website to see where the zonal gateways can help you and how our products fit within these gateways as you're developing these types of products.
So, Kirk, I would imagine that the space saving element of the HFM PCB headers would make these solutions a great fit for a lot of different applications.
That's right. And what we're seeing is any area where people need a lot of coax coming into a system, they're looking at HFM as a fantastic product to give you miniaturization, which allows you to fit a lot of interfaces into a smaller box. The video processing module that we show in the upper left corner here is designed around an automotive system, but we're also seeing it in areas like security systems where you have multiple camera inputs to a centralized location. The HFM is a fantastic method for tying all these coax cables together.
All right. So, Kirk, can you also walk me through the implementation of these FAKRA mini connectors in an automotive design? What would that look like?
Well, we're showing here some of the current applications where the HFM has taken over from the FAKRA. We start with the traditional telematics antenna, or as we know it, the shark fin antenna that we show in the lower left corner here. Typically, there are 4 or 5 FAKRA interfaces on that antenna. They tend to be individual cables. And in an automotive assembly line, you have to plug in each one of those separately. By switching to the 4-port HFM product, we're able to put all of the signals in that shark fin antenna into a single quad HFM product. So it helps from a miniaturization as well as an assembly time standpoint. Our automotive manufacturers estimate it takes between 10 and 15 seconds for an assembler to connect each one of the systems in a vehicle. And if you can eliminate 4 with 1, that saves you close to a minute of assembly time, which is huge when you're building hundreds of vehicles a day. The other picture we show here highlights the surround camera system, where again, the signals from all of those separate cameras come to a single 4-port product in the electronic control unit.
Excellent. Okay. So, Kirk, are there any other cool applications that you'd like to share?
Yes, very much so. I'm really excited about the applications we have in the agricultural market. To give you an idea of products that are currently available today, we're highlighting in the upper picture a visual weed spray system. And in this case, our customer has a weed sprayer that actually has 36 individual cameras, each one tied to an individual herbicide spray nozzle. And what they do, the vehicle moves through the field, the cameras visually identify weeds and spray a metered amount of pesticide on that weed. So the savings here for the farmer are huge because instead of spraying an entire field and having a lot of that pesticide go as runoff, metering it can save them thousands of gallons of pesticides as they're spraying their fields throughout the crop life cycle. The other area we're highlighting is an automated fruit and vegetable harvesting system. In this case, we have a system that visually identifies strawberries. Now, remember, these are high-end strawberries, but the way the system operates is the little robot goes up and down the aisles 6 or 7 times a day, and as the strawberries reach peak ripeness, they individually pick each one by using the camera system that's tied in through an HFM connector and the coax signal.
That's super cool. All right. So, Kirk, can you recap your main points for me?
Sure. The key thing to think about is in transportation, coax is so much more than AM/FM radio. I'm old enough to remember when the only coax in my vehicle was that AM/FM antenna, and we have dozens of coax applications in vehicles today. The other things to note is that cloud connectivity that we're all wanting to see in our vehicles drives a lot more need for data, both internal to the vehicle as well as external data connection. We talked about things like V2V, the vehicle to everything, home networking, digital cameras. All of that drives a need for data, and the HFM product is an excellent product for doing that. Again, the mini piece of the HFM name highlights the fact that the parts are much smaller than existing coax signals today, which enables you to better architect a vehicle moving forward. The other thing to note is within our mini coax system, we offer significantly higher speeds than current transportation grade systems. We're certified today at 9 gigahertz. We expect to be at 15 gigahertz as the cables catch up. And then the smaller size gives you a lot smaller footprint, enabling you to pack more features in the vehicle. And I can't stress enough that one of the other key advantages of this product is that it is in stock and ready to ship from our distribution partner, Mouser.
Fantastic. All right. So to wrap things up, Kirk, what does Molex bring to the table here in particular?
Well, Molex has decades of design and engineering collaboration and experience with both automakers and tier one suppliers. We participate in quite a few of the automotive standards, so we're able to develop products that meet a broad range of industry needs. We've got best practices for our engineering and a lot of experience with rugged, long-lasting vehicle interconnections. This makes sure that whatever system you're designing, the connector will support improved reliability, allow you to seamlessly integrate with other automotive subsystems, and also simplify your assembly and maintenance. So what we're asking you as our customers to do is hit the road together with us. Molex is the design partner, Mouser is our supply partner, and between the three of us, we'd love to look at your new designs and figure out ways that we can both work together and be very successful with high-speed, either RF designs or digital camera designs or Ethernet-based designs.
Fantastic. Well, Kirk, I think that's all I have time for today. Thank you so much for joining me.
Thank you. Appreciate it.
And before we go, you didn't forget to click that link, did you? There you can find even more information about this topic from Molex. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talk section of EE Journal. You can't miss it, it's right across the top. Or head on over to YouTube, youtube.com/EEJournal.